Hey pre-calc class, just leaving you a really quick video in case you get stuck on any of those the problems that you have for review. This is all stuff we've been working on but kind of jumbled together. So I'm just going to talk you through some strategies. There's a couple trickier ones that we want to maybe take a look at. And then you want to turn this in before class on Monday. And don't forget to turn in your 4.4 practice set as well. The answers are on Schoology, so you can check. Okay. For the first two questions, this is exactly what we did on Tuesday. So when you see log base 5 of 500, you want to try and rewrite 500 with 6, 7, 4. And remember, you could also use the base of 5 because we learned log base b of b is equal to 1. So I know log base 5 of 5 is equal to 1. So you can use 5 in addition, rewrite 500, and then expand using your properties. So if they're all multiplied together, expand it with addition. If they are, if you have something raised to a power, remember that becomes a coefficient. You can clog it. And if you are using any division, then it can become subtraction. So try and rewrite those. The next section is evaluating, so you might be able to do this in your head or you might need to write it out, but the idea is to figure out what it's equal to. That's how we would evaluate. I would transfer it into an exponential equation, right? So this is 7 is the base of your exponential. So 7, this is my exponent, to the power of x equals 343. Yes, you can use a calculator if you want to figure out 7 to what power equals 343, but I bet you could do it with that one. So you're really trying to figure out what's the exponent on the base that gives you the value you're taking the log of, okay? Here we're condensing, so just use your properties that we looked at on Tuesday to help you do that. The only thing that I thought might trip you up is like number 9, number 10. You have log base 3 of a over 3. So remember that this is the same thing. If I put it over 3, that would be the same as 1/3 log base 3 of a. So if it's easier to look at like that, you could write it in that way. Okay. So the 1/3 becomes your exponent, which then we need to go back and think about what kind of radical the 1/3 power creates. So you're kind of creating a radical there. So see if you could simplify those. And then here you're expanding. So use your properties to pull that apart. We're not solving in this case, just see how far you could pull it apart. This is connected with multiplication. Again, if you have a cube root, that's the same as the power of 1/3. So think about that. See if you can write it in its fully expanded form. And then down here is where you're actually starting to solve. The first few, looking at using your one-to-one property, if I have the log with the same base on both sides, then I know that what I'm taking the log of must be equal to each other, right? So I could say 27 equals negative 2m minus 1 and solve that. When you get down to 20, now there's no longer just one log on each side, right? Remember, one log on each side before you can use your one-to-one property. So if you see them connected with subtraction, think about using your log properties to condense that first. So write it as log base 4, and then we know subtraction changes to division. So 7 over x equals log base 4 of 6, and then you can solve from there. Okay, I didn't put too many super complicated ones down here, just practicing those properties again. And you had a few like this on your 4.4 practice set that were a little trickier with the quadratic setup. So hopefully if you check your answers, you got those. If you have questions about anything, save them for next class and we can talk about them on Monday.